You're up if you're ready.
Okay, let me share screen. Okay. Well, anyway, this is this is just a star cluster in Orion, and of course, some people might could be forgiven for thinking this is M37, but the star cluster happens to have the fortuitously have the have their stars configured to trace out the number 37 for no obvious reason. So I just thought that was rather cute.
Yeah.
Yeah, I think I see some dark matter behind it too.
Yeah, you can actually see it. Anyway, I found out about this thing in an observers list in Sky and Telescope from earlier in the year. I can't seem to quite locate it, but it's located in the right arm of the upstretched arm of Orion, and so this was an observing list for objects in that region of Orion. I just showed that just because I thought it was kind of interesting to see the pattern.
Oh, it is. That would be holding the club, right?
Yeah, right. Yeah. Okay. Yeah, I don't have any specific meaning associated with the number 37, or is it associated with any sports stars jersey number or anything like that? So just number 37 in stars.
You bet it was 42.
Oh yeah, right. Okay. Okay. So anyway, next thing is this is actually a galaxy in Leo. This is NGC 2903. I thought it was a nice typical barred spiral, and here's an enlargement of that image showing what the thing looks like. You might notice that there are extensions of the spiral arms way off to the left and way off to the right in the upper part of the image, and how far that goes is here's something I've been sort of playing around with, is putting the image up in Photoshop and then inverting it to show it with black on white instead of white on black, and in the hopes that maybe I would find something interesting. Haven't yet, but I just wanted to show you what I've been doing. I know that in the early days of astronomical photography, a lot of astronomers used to do this kind of inversion in film or on glass plates, and they were often able to find some new features by processing their pictures in that way, and I'm sure that astronomers are still doing that to some extent. Okay, but to show the full extent of those spiral arm extensions, I pulled up this picture of this galaxy. I think it was done by Tony Hallis, that shows the full extent of those, the highly enhanced image, obviously showing the full extent of those spiral arms and how much bigger they are.
NGC 2930?
2903.
2903.
Right.
And that was in where?
In Leo. It's located sort of midway up the sickle of the head.
Yes.
Okay. So I recall, I think Mike Cook and I think maybe Ed Perret may have covered a lot of galaxies in Leo, but I noticed that this one was missing, and I thought this was a good one that shouldn't be missed. Okay. Anybody else have anything else to show? I'll go on to the next object then. Last night, the other night, right, Thursday night, I took a picture of M51 for the first time. I think that's been shown before, but I have a little bit more to talk about with regards to M51 that was spoken earlier. So this is my initial full frame image, and this is the enlarged image to just show how much detail the EV scope is capable of showing. And there's also a little color too. It's a little bit weak.
We've noticed the EV scopes give us more color than any other scopes.
Well, they are a full color chip. Right. That's true. Although I think they suffer from the same problem with their eyes do, is if the light intensity is weak, it doesn't see color all that well, actually. But anyway, that's the classical view of M51 through the EV scope. I also did an inversion of it to see how much more detail I could see in the opposite version, and that's what that looks like.
Yeah.
Now, M51 is an iconic object, and it's been observed for a long time, starting with Lord Ross in the 1840s, who did drawings of this thing using a 72-inch telescope, and this is one of his drawings from about 1845. Okay. He used this telescope, the 72-inch telescope, which we actually visited with the Antique Telescope Society back in 2002. And so you can see all of us geeking out and climbing all over this thing, which has been partially restored to some level of operativity back in the 1990s. And let's see, that's me standing on the observer's rail, and you can see how far up one is up above the ground level to gain access to the Newtonian focus of this
Well,
telescope.
Ken, was there ever a larger reflecting telescope before the big hooker scope, the 100-inch?
Well, there's the biggest scopes before Mount Wilson was the 48-inch by William Herschel,
Yeah.
which was back in the late 18th century. That stood around until about the 1840s, sort of in a semi-ruin, and then finally demolished. Although the one half of the iron tube still exists, and it is an exhibition at the old Royal Greenwich Observatory. And so when you go to that observatory, you can actually see the old tube. And then the next one would be Lord Ross's 72-inch, which is about the mid 1840s.
Nothing nothing bigger than that though until
Nothing bigger than that until the hooker actually came online, right? And then, well, then in terms of large reflectors, there's George Willis Ritchie's 24-inch at Yerkes, which all of you have seen as an exhibition at the Chabot Space and Science Center when it was borrowed there, and that was the first practical glass, silver on glass reflector up until, but I think that was built about 1900. And then the 60-inch came into service in 1908. And then the 100-inch was started operations in 1917. Okay, so actually for quite a long time, this telescope was the largest telescope on Earth, but it was not very practical, and it was very large, and you can see it was
that a speculum metal instrument?
That was a speculum metal telescope. That's correct. The mirror for this, the original mirror, one of the original mirrors for this telescope still exists. It's on display at the Science Museum in Kensington on the west side of London. So if you go to the Science Museum there, you can actually see one of two mirrors. I think the other mirror was broken up and lost, but the one that remains as an artifact is in London. And then the telescope, this telescope was in a state of total disuse and disrepair for about 100 years. And then in the 1990s, a retired engineer by the name of Michael Turbiddy supervised the reconstruction of this telescope. So the wooden observing platform there is a rebuilt one. Obviously, the old one doesn't exist anymore, but is made of wood and would have rotted by now. So anyway, you can see how far up you had to be on this telescope to use it. And I'm surprised that there are no accounts of anybody falling off and getting killed. Now, it's interesting to note that going back to this image, my image with the 4-inch is actually, I think, much better and obviously more accurate because it's a photograph than the drawing that was done with a 72-inch, almost 180 years ago. And so things have improved definitely. And Lord Ross needed to have the resources to hire about a dozen guys to maneuver this thing around, and a whole workshop in order to maintain the thing. So it was not not an easy
Yeah.
telescope to use.
You had to,
But
a speculum metal scope, you had to be constantly polishing one while you were using the other.
that's correct. That's why he had two,
And-
but only one of those exists anymore.
And
Anyway,
it was a transit scope too, so you could only.
it's a transit scope, so
cross
your
the zenith, yeah.
your side-to-side motion is limited. But anyway, there have been some supernovae found in this galaxy, and here's one example of which is up here at the intersection of these two arrows. And here's a Hubble Space Telescope view of M51, and that's the classical view. But this view was recently taken from the Sophia Airborne Observatory, which Dr. Dana Backman talked about back in February. And this was published, this picture, actually, I found out about this in the latest issue of Sky and Telescope, the May issue. What the Sophia people did was they mounted a polarimeter on the observatory, on the telescope in the Sophia aircraft, and this allowed them to map out the magnetic field of the galaxy. And so in the central part of the galaxy, the magnetic field lines basically follow the spiral structure of the central part of the galaxy, but there's a sort of a more chaotic and randomized distribution of these magnetic lines in the periphery of the galaxy. And this is these disruptions are thought to maybe due to one is that there's more star formation going on in the periphery of the galaxy. And you can see these red H2 regions where there's a lot of star formation taking place. And also maybe there's some disruption as a result of the grazing collision with the satellite galaxy NGC 5195. So anyway, that's just a bit of a quick story about M51. Okay, so anyway, I don't know if Ed is ready to do anything.
Mike, why don't you go ahead and show us what you got?
All right. So what you have here is this very faint galaxy, which is IC 3322A. And
Those two I don't see. Huh?
yeah, it's a very faint one. But then you see this bright blue star right here. That is a supernova.
Oh.
That is 2021 HIZ. It was first seen on March 30th. And it is.
Okay. So I can see a little hazy.
See, there's a hazy
line. Yeah,
Yep.
right. I see that.
That's
Okay,
the galaxy.
That's the galaxy, right?
Yep, it's a pretty faint galaxy. It's IC 3322A, and then the bright blue thing, it's brighter than the entire galaxy, is actually the supernova.
3322A. What constellation is that in?
I do not know. There was I just got I read about it and got the
coordinates.
basically the address, the
coordinates.
Coordinates to it. There is about 3 supernovas I can see from my house right now.
Wow. Okay.
And they're fairly. This one I think is the brightest of the ones I can see. This was again discovered by the Zwicky Transit group. It is a Type 1A. It's in the constellation of Virgo.
Oh, okay.
I'm looking it up real quick for you.
Where are you located with the scope?
I'm in San Mateo.
Okay. Where rough? Are you up in the hills or?
No, I'm by the bay.
Okay.
Oh, he's off 3rd Avenue in North San Mateo.
Yep. So it's let's see. I'm trying to see if I can find my page real quick.
What's the length of your exposure on this image, or is this ongoing?
It's live. It's been 15 minutes.
Okay.
So yeah, it's a live shot.
So it's still densifying.
What's the field of view? This is a unistellar UV scope. So you have 1.5x. I assume.
Yeah.
Just slightly magnified from the full camera field of view.
That's the default.
Okay.
And then that's a 2.5 zoom in.
Okay.
Can you brighten it up on your image enhancement, or is that possible? I don't know.
Well, I mean, it's because of how little it's been
Exposed, yeah.
exposed is more or less the case. It's pretty far out. I've got I have a shot I did before where it's been going for 45 minutes and you can see the galaxy much better. But
Okay.
the case is just how much brighter, obviously, the supernova is in the galaxy itself, which is, sort of what the standard statement. And this particular supernova, according to the Rochester Astronomy or the supernova page, is 13.4 magnitude. So it's kind of one of the brighter ones available right now.
15.4. Wow, that's pretty
13.
good.
13.
13. Okay, it's still pretty good.
It's even brighter.
Yeah.
About 5 times brighter.
Yep. So it's really pretty bright. Anyway, that's what I had to show is really faint galaxy, but a bright
supernova. Wow.
Yeah.
That's a type 1A. Okay.
Yeah, type 1A. In fact, there's 3 type 1As I can get from my backyard right now.
Oh,
There's
Oh,
something.
good.
That's a M104.
Yeah, that's a sombrero.
Okay.
And it's live. I mean, I just moved over there. It's about 11 minutes to spend on it.
That's still pretty good. That's a pretty bright galaxy, though.
Yeah, well, I've got a lot of haze up here. I'm up in the hills. There's an awful lot of haze and a lot of bright light in the haze. I'm not seeing much.
It's not a clear night for sure. Even
And you can see the light on the sides from the haze and the lights around here.
Yep. Yeah, mine was even worse at like 1 or 2 minutes and
Yeah.
before it got usable.
But on the other hand, compared to what I used to see with my 8.8-inch, it's amazing.
Oh yeah. I got no complaints.
Yeah.
Yeah, it is amazing. I mean, little 4-inch telescope beats out my old 8 and 9.25 inch.
Yeah.
And also gives me an image to keep as a keepsake.
Yeah. Yeah, it's a lot of fun.
That's good. No, it's great.
Okay, but that's basically what I have. It's not really going to.
Oh, that's always a good image. Always a good object.
Yeah.
Reliable.
Pretty.
Yeah. Well, I had to get something bright.
Okay, so that's the Sophia view of M51's magnetic field lines. Now, one of the things I've been concentrated on right now is looking at galaxies in Canis Venatici, of which M51 is the most famous. And so the next one that I got, there's more interacting galaxies in Canis Venatici than just M51. And this is an interesting interacting pair called NGC 4490, which is the big component, and 4485, which is a smaller component. And so these are 2 galaxies that are also grazing across each other, just like M51 is, although not as prominent and famous as M51. So anyway, here's the enlargement of what this galaxy looks like. Actually, I really like this galaxy visually, because basically what I see through a telescope is basically what is also shows up on a photograph. So there's no hidden features on this thing. So as a visual object, this is actually kind of photographic in comparison to other galaxies where there's lots of fainter features that cannot be seen visually.
Yeah.
Okay. So anyway, here's the inverted view, and that's what that looks like. And then this is the Hubble Space Telescope view of the central part of NGC 4490, and you can see all the H2 regions where there is a star formation going on. And what else? And there was a supernova in 2008, which is pointed out by the caption there. And anything else?
That's
Okay.
fun. Funny there, Ken. Last couple of weeks ago, this was one of the ones I was interested in and looked at, and I looked at a series of these distorted galaxies.
Yes,
One
yes.
of them as well. Did you
Right.
look at the hockey sticks?
Yes, I did. And I tried to take a picture of it yesterday, but for some reason my equipment shut down, even though I was plugged into the wall current. And it was like 12:30 at night, and I had to get up in the morning. So I'm going to put that off until next month, maybe.
Well, I got a stock one I can show too, because I grabbed that one and
I have a stock one too, but I'm gonna until I get my own image.
It was
I
my
probably won't pay
image. I just meant not a live one.
Well, there's two galaxies in that general field of view, although the field of view of the EV scope is too small to encompass both of them in a single field. So you need a wider field telescope to get them both in. And actually one is coming on the market by a company called Veonis. Have you heard about them? They make another alternative to the EV scope that's similar in operation called the Stellina telescope.
Oh, yeah, I've heard of that one.
Yeah, and then they're coming out next year with a smaller version, which is 50 millimeters and I think about 200 millimeters of focal length. It's a refractor as opposed to being a reflector. And so judging from what the videos that I've seen about these telescopes on YouTube, it looks like the star images are better than that of the EV scope, simply because the refractors don't have the coma problems and the secondary diffraction patterns that come off the secondary holder or the chip holder at the top of the image tube. It's just a different configuration, and I'm thinking about the smaller one because it would give me access to a wider field of view later on. And I think the thing also costs obviously a lot less because it's a smaller telescope. It's about $1,500 as opposed to I think $4,000 for the full size Stellina, which runs about 4,000. Yeah, 4,000. So that one has similar specifications as the EV scope. Okay, but anyway, do you want me to go on? I have one other thing to show, I think.
Sure.
Yeah, sure. Why don't you go ahead and show that one?
Okay, and so another interacting galaxy is this thing, which is what NGC 5395 and 5394, which is a smaller component. And when you magnify this up, you can see how these are actually two interacting galaxies, one of which is a spiral, and then the other one is kind of a smaller barred spiral off in the background.
Is this also in Canis Venatici?
This is also in Canis Venatici. That's correct, right? And so that's my magnified view of that image, and this is the inverted image. So I've been concentrating on Canis Venatici while everybody else is looking at Leo and Ursa Major, because I thought that there was a constellation that wasn't we weren't quite paying attention to. But I have more stuff on Canis Venatici. This is a picture from Adam Block from Mount Lemmon in Arizona, where he used, I think, a 30-inch, a 1 meter approximately telescope to image the same galaxies, and this gives us a better detail about how these two galaxies are interacting.
Wow.
So that's pretty interesting. So I think that is all I have to show. Yeah, that is all.
You say interacting. Does that mean they're just line of sight, or that they're actually supposed to be at a comparable distance?
Well, they're
one hit the other, and it's sucking it up like M51.
Right. It's kind of like an M51 sort of interaction. It's also not that dissimilar to what's happening with the NGC 4490 and 4485 that I showed earlier. Right. So these are these are at least 3 galaxies that are, I thought were interacting galaxies. And that's the underlying theme of all these images. They're interacting galaxies in Canis Venatici. All right.
Very nice.
Okay. So I think that's all I have to show.
This is NGC 3147, and it's a type 2 Seyfert galaxy. And the blue out here on the very edge, if I had more time, you'd start to see a little bit more of it come in. But right on the edge, that blue is another supernova.
Oh, wow. Okay.
PR.
What was the number of that supernova?
21 HPR.
Huh.
And that is a 14.4 magnitude, and again, a type 1 supernova.
That's neat. That's great. What's the, is there an estimated magnitude for that supernova in the
14.4.
specifications?
14.4.
14.4. Okay, I didn't hear. Okay.
It was first seen on April 2nd.
Okay.
So I found this site supported by Purdue University that sort of tracks all the supernovas with a magnitude over 17.
Mm-hmm.
And just been seeing which ones can I find, and which one I can see in my sky. So I was able to grab 3 of them.
That's great.
Yeah, there's supposed to be one too in Cassiopeia, but I can't get to it yet. It's behind trees in my yard, so I have to leave my house.
Do you quarter explosives in your house? Because you got all these supernovas going off around.
Yeah, exactly. And let's see, I'll throw out just one little thing, since it was a little bit about the talk we just had. Well, not sort of. Something else I had finally sort of been putting together over the last month or so. This is the Markarian chain.
Okay.
So as you can see, it's several different pictures that I've taken with the EV scope, and I got these last 2 in last night.
Oh.
And so M87 is just below all these, but this should be M86 and M84, if I remember right. I'll double check myself. Yeah, M86 and M84 are the big ones there, right? That's M86, M84.
Those are around Earth to nature.
Galaxy, and these are the I galaxies, because they have a big halo of gas around them, and it just keeps going.
I remember last year Ed Perret took a picture of a M87. This was before I got my EV scope. Actually, he was ahead of me on that one. And I tried to, I don't know what his exposure was, but I tried to bring out the jet that was coming off the black hole, but I couldn't bring it out from his image.
I didn't know that was invisible light. I thought that was in light you couldn't see.
Oh no, it's actually an invisible light also. So with a big enough telescope and long enough exposure, you can acquire it. And actually, I think it was first discovered on a ordinary photographic plate back in the 1930s. They had no idea what it was, but that was how it was discovered.
Yeah. I'm hoping to continue and be able to connect M87, because I have that. I have that whole Virgo cluster, all the big M's in the Virgo cluster, and see if I can continue to add. But at least I've gotten that much of it complete.
Okay, that's great. That's great.
And I think we mentioned this.
Oh, there's the hockey stick.
Yeah, this is the hockey stick. So it's 2 galaxies. There's one like right there that's sort of bending this piece here.
I think it's 5630.
4637.
4637 or something.
4657. Yeah.
57. Yeah.
Yeah.
I did take a picture. I did take a picture of the bigger one, the whale.
Oh yeah, I got the
Galaxy.
whale. That's the whale.
Last night, but I'm not. Yeah, you're showing it, but not me.
Yeah, that's the whale there.
I wanted to stick with the interacting galaxies.
Yeah, but this one's also, like you said, another distorted galaxy. It's probably, this galaxy here may have distorted it, but it's
We were talking about satellite galaxies
yeah,
tonight.
the
so-
satellite. What I was reading about it, it was just talking about how it's front heavy here. I got it very much like yourself got interested in these. Yeah, so here's the one you showed too.
Oh yeah, the 4490. Yeah.
Yeah. I got interested in these galaxies that are sort of distorted. So
Yeah.
I have a very interesting colliding set. This set here is I can't remember how many. Let me show it. It's really far away and very faint. I'm blanking on just how far. But I was able to sit on it long enough to get it to where I could bring it out a lot in Photoshop to show it. But this is NGC 5278 and 5279. And they're, again, they're colliding and interacting. Let me see. And if I remember right, they are crazy far away.
Yeah,
And
I think
really
I think 14.4, if memory serves, is about the limiting magnitude for visual on a 6-inch reflector. But it's greatly affected by conditions. That is, if the sky is hazy or if the surrounding sky is bright or something like that, you may see a good magnitude less.